We have two goals in this problem. First, we need to draw all the vectors on the coordinate axis with their tails touching the origin. Second, we want to solve for the resultant vector that represents the individual vectors a and b. Here's our coordinate axis. First, we will draw a. It is 10 units long and acts at an angle of 45 degrees below the negative x-axis. For vector b, we are given the x and y components of the vector and want to draw them. First, we place bx on the grid. Next, we draw by. Now that we have our vectors drawn, we're going to add them together to find our resultant vector. We'll create a table to help us sum our components. Here is the vector triangle for vector a. We will break this down into its components and input the values into the table. The x component of a is negative. The y component of a is also negative. Here's our vector triangle for vector b. The components of b were given to us in the original information, so they are easy to find and input. bx is 2.0 and by is 4.0. Now we will sum the components in both the x and y directions to find both rx and ry. Rx is negative 5.07. Ry is negative 3.07. From these components we will draw a vector triangle for the resultant. First we draw Rx, then from the head of Rx we draw Ry. Finally we draw the resultant from where we started to where we finished. Now we can solve for R. We will use the Pythagorean theorem, substitute in our numbers, and find the magnitude of our resultant. To find the angle we use tangent, substitute in our numbers, and find our angle. We will write out our answer in magnitude angle format. Notice that R is in the third quadrant.